Hello friends, today's question. A particle executes simple harmonic motion with a frequency f. The frequency with which its kinetic energy oscillates is. So these are the four options. Okay. So it is said that the particle is executing as SHM with the frequency f. So we say that let the position of the particle at any time t be x. Let position of the particle at time t be x. Therefore, we can write an equation for x. Say position of particle which is x will be equal to a sine of ft, where f is the frequency of SHM and a is the amplitude of oscillations, where a is the amplitude of oscillations and if we say that v is the velocity of the particle, then we can write its kinetic energy will be equal to half mv square. For v is the velocity of the particle, then v will be equal to derivative of the distance x, that is dx by dt. Therefore, v is equal to dx by dt. Substituting the equation for x, we get d of dt and x is a sine of ft, and this gives us af cos ft. Now kinetic energy is half mv square. Kinetic energy of the particle having mass m, and this will be given as kinetic energy is equal to half mv square. Substituting the value of v, we get this is half m. We have a f cos of ft and its whole square. So we get this as kinetic energy will be equal to half m. Opening the square, we get a square, f square and cos square ft. Now we can expand this cos in terms of a multiple angle. So we can write cos square ft will be equal to 1 plus cos 2ft divided by 2. Therefore, kinetic energy will be equal to half m a square f square, and here we can write 1 plus cos 2ft divided by 2, which can be further simplified as 1 by 4 m a square f square 1 plus cos 2 ft. Now we can just modify this equation let me write it here again, that kinetic energy is our 1 by 4 m a square f square and 1 plus cos 2 ft, which can be written as 1 by 4 m a square f square 1 plus cos f k t, where this fk is equal to twice of f. Okay. So this is the kinetic energy of the particle having the oscillations kf, and which is equal to 2f. Okay. Therefore we can say that the frequency, this is the frequency with which the kinetic energy oscillates, and is equal to 2f. So 2f is the frequency of oscillation of the kinetic energy. So the option number C is the correct option. Option C is correct. So this completes the question. Thank you.